Hello, geometry students. For today's notes, you will need in-class 50. This is the first part of standard 12. We are going to be learning some new techniques to solve for the sides of right triangles. So to get us started, we're going to build off of our knowledge of the Pythagorean theorem. We have a couple of triangles here where 2 out of the 3 sides are given. So if we remember what we know about Pythagorean theorem, we would identify C as the side that is opposite the right angle. So this c squared equals a squared plus b squared equation would look like x squared equals 3 squared plus 3 squared. Feel free to pause this and then to come back and watch once you try these if you'd like to try them on your own. X squared then will be 9 plus 9, which means x squared is equal to 18. And at this stage of the game, we would have square rooted on both sides. And then we would be working to see whether this answer is simplified or not. So if we think about the square root of 18 using either your factor trees or your factor tables, you're going to be able to identify that there is a perfect square factor of 9. And so the official simplified answer for x would be 3 root 2. If we do that one more time here with this example, the only thing changes is that the 2 sides that are legs are going to be 5 instead of 3. So we'll get that plugged into our Pythagorean theorem. That means that we're going to be dealing with 25 plus 25, or x squared equal to 50. We'll square root both sides again, and then like before, all that will be left to figure out is whether the square root of 50 can be simplified. Again, factor trees, factor tables, or perfect squares should lead you to simplify square root of 50 as 5 root 2. And so what ends up happening is if we are focused on using isosceles right triangles, which is what both of these are, we know they're isosceles because they have 2 legs that are congruent, 5 and 5, or 3 and 3. We know they're right triangles because of that right angle we've been using. Then there's going to be a consistent pattern that happens when it comes to the relationship of the sides. These 2 sides are always going to match, and it looks like this hypotenuse is going to end up being that same length but multiplied by root 2. 5 and 5 match, and then the hypotenuse is 5 but then multiplied by root 2. And so that pattern we're going to say is that a leg will be equal to L. There's going to be 2 of those that are equal to the same amount. And then the hypotenuse of the triangle is going to be equal to the leg multiplied by a root 2. So we've got the pattern L, L, and L root 2, where these are the legs connected to the right angle, and this is the hypotenuse. If we investigate this a little bit more and we recognize that this is an isosceles triangle, we can actually figure out something about these angles as well. If we do 180 minus this 90 degrees, that means we have 90 degrees left over. And when those get split between these 2 angles, our angles will always be 45 degrees, and then that right angle that we started with, which is why the title of your notes today is 45, 45, 90, special right triangles. So another indicator that this relationship will work is not just knowing that this is isosceles necessarily, but seeing a 45 degree and a 90 degree angle in the corners of our triangles. As we get into this idea, because there's a root 2, there's going to be several instances where we're going to need to multiply by root 2 or later on divide by root 2. So we're going to work on just some foundational skill practice with radicals to make sure that part of the process will be pretty easy. When you're multiplying radicals, they are going to combine together. So this will be 6 root 4. And then sometimes that simplifies. In this case, root 4 is just 2. So this ultimately then just becomes 6 times 2, or 12. For number 2, the radicals have different numbers underneath, which is fine. We can still multiply those together to be 3 root 6. But root 6 doesn't simplify like root 4 did. It doesn't equal an integer. And if you try to come up with a factor tree or a factor table, none of the factors for 6 repeat in your tree, and none of the factors can be square rooted from your table. So this is just 3 root 6 in its exact simplified form. Number 3 is really similar to number 1, so you might even notice when these match that you can just jump straight to the 11 times 2. That's really happening because this is 11 root 2, but squared. And we have worked on squaring roots, and we know that that number underneath the radical sign ends up being the only thing that's left when we do that operation. So for number 3, we'll end up with 22. For number 5, we've got 10 times 2, so that's going to start as 5 root 20. But if we look at the square root of 20, there's probably going to be the ability to simplify that with one of our methods from before. If you're looking at factor trees, you're going to see a set of matching 2s. If you're looking at your factor table, you're going to find a row where 4 gets multiplied by 5. And so if you're thinking about any of those methods, there's going to be a 2 root 5 that replaces that root 20. That 2 root 5 is going to get multiplied by that original coefficient. So the ultimate simplified answer for this would be 10 root 5. For 5 through 8, we're switching into solving mode. So to get the x by itself, we're going to end up dividing both sides of the equation by root 2. Root 2 divided by root 2 is just 1, and so that leaves us with just 1x, which we typically just write as x. And then the same thing happens on this side. Root 2 divided by root 2 is 1. 1 times 7 is just 7. We don't end up with something as positive on number 6, because when we divide in number 6, we have an integer and a radical. Those do not play nicely together. So there are a couple of things that you can do here to try to simplify this. When you have 10 divided by root 2, we could choose to do what's called rationalization of the denominator, which is to multiply both the numerator and the denominator by the same number. This is really just equal to 1, so we're not changing the value on this side. What we're doing is we're moving the radical to the numerator, and then on the bottom, that root 2 times root 2 does the same thing that it did up here, and it just becomes a regular 2. And now that 10 and that 2 that are both integers can be simplified to give us an answer of 5 root 2. There's another method that you can use for this if you don't like this rationalize the denominator approach. I'll show you that when we get to number 8. For number 7, we need to divide again by root 2. This time, though, there's a root 6 available. 6 divided by 2 is 3, so that's going to become a root 3 attached to that 17 when that's simplified. When we move to number 8, again, the approach would be to divide on both sides by root 2, but I'm looking ahead and I'm noticing something similar is going to happen to up here. So another option, if dividing by root 2 isn't really possible, is to do something a little bit strange and to actually multiply both sides by root 2 instead. We've already reviewed today that root 2 times root 2 is regular 2. So we haven't isolated the x yet, but we've turned the root that was attached to it into an integer. And then that gives us an integer that's a little bit easier to divide by. In this case, 9 divided by 2 doesn't work as nicely as 10 divided by 2 does. So we typically don't write a decimal out front. We would just leave this in fraction form. So x is equal to 9 root 2 over 2. Okay. All of those ideas are going to help us as we go through and we solve for missing sides in these new special 45, 45, 90 right triangles. My suggestion is that you always start by labeling based on the relationship that we identified up above. So we know the legs are always going to match and the hypotenuse will always be the leg times root 2. So if we set that up to begin with, these are our legs attached to the right angle, and across from the right angle is the hypotenuse. So both of these will be equal to L, and then this will be equal to L root 2. I can see that I already know what L is equal to. So now that L is equal to 3, I can take that 3 and plug it in everywhere else I see an L. So this basically becomes 3 equal to n, and I'm done solving for n. And this becomes m equal to 3 root 2. And I'm done solving for m. Root 2 can't be simplified, so those are my two answers. n is 3, and m is 3 root 2. Taking a look at number 7, we've got our two legs right here, so those are both going to equal L. We've got our hypotenuse across from the right angle, which is equal to L root 2. Again, I can tell right here that 7 is going to equal L, so everywhere I see a 7, everywhere I see an L, I'm going to plug in 7. Again, not too much left to do. 7 is equal to n, and m is equal to 7 root 2. For number 3, we've got our two legs here attached to the right angle, so these are both going to be equal to L. Across from the right angle is the hypotenuse, so that will be L times root 2. We still have an answer for what L is equal to, but that's a little bit more complicated than just a 3 or just a 7, so make sure you're careful here. You take that whole 2 root 2 and you replace every single L with it. So B is equal to 2 root 2. A is equal to 2 root 2, that's the L, but then there's an additional root 2 that gets multiplied by that L. B equal to 2 root 2 is a simplified answer. That's okay to leave. This is not. So what we need to do before we finish these is just like in our previous standard, we want to give our answer in simplest radical form, which means the first thing I want to do is combine those roots together. That'll become 2 root 4 if you want to write it that way. Or you can think about how root 2 times root 2 should just be 2. So A is going to simplify to be 4 at the end of that process. Number 4, we've got a 45, 45, 90 again. So the two legs are both going to be equal to L. The hypotenuse will be equal to L root 2. I still have information about what L is equal to, so I'm going to plug that in everywhere I see an L. Y will equal 5 root 3, plugged in for L, simplified, so we're done there. X will equal 5 root 3, that's the L, remember, so we need to attach a root 2 onto it. This isn't considered simplified, so we're going to take our root 3 and our root 2 and multiply them together to be root 6. Earlier when we got a root 6, I kind of talked you through the fact that it was already simplified, but let's just say you weren't sure. If you're a factor table person, you'd try to square root 6 and it would give you a decimal. Your next pair of factors would be 2 and 3. 3 doesn't square root without being a decimal. That's a complete factor table because these are right next to each other, so once we've moved down this way, we loop around and we try to go up. Can't square root 2, and square rooting 1 doesn't simplify anything. So that's why this is already a simplified answer. All right, go ahead and flip the page and meet me back here for some more examples. Moving to the next page in your notes, we're just going to keep right on using the same relationship because we still see 45, 45, 90 right triangles. Remember the two sides connected to the right angle are both the legs, so they're both equal to L. Across from the right angle is the hypotenuse, so that's equal to L root 2. We still have a clue about what L is, so we're going to plug that in everywhere we see an L. So 5 is equal to n, and m is equal to 5 root 2. For number 6, we've got a 45, 45, 90, so the two sides connected to the right angle are both the legs equal to L. Hypotenuse is equal to L times root 2. We still know what L is equal to, so this time 7 root 3 is going to replace all of the L's. That's going to be it for V, because 7 root 3 is on its own, it can't be simplified. But for U, we have our L, 7 root 3, needing to be multiplied by root 2. So our final simplified exact answer for U would be 7 root 6. The last one of this set, we're going to have these two legs of our 45, 45, 90, both equal to L. The hypotenuse is always equal to L times root 2. We do again have a clue about what L is equal to, so we're going to take root 10 and plug it everywhere we see an L. If they give you a side length for a triangle, it's already simplified. But if you wanted to, like let's say we were testing factor tree people here, we would split it to be 2 and 5. Those don't match. There are no other factors, so that kind of confirms that root 10 was already simplified. When we take that L and we plug it in up top, though, we end up with root 10 times root 2 equal to m. I'm going to work on that over here to the side because I can't leave those two roots sitting next to each other, so I'm going to multiply them to be root 20. And then root 20, we're going to check to see if that needs to be simplified. Last time I did a factor table, so this time I'll go ahead and do a factor tree. Maybe I pick 2 and 10, and then 2 and 5. I'm noticing that I have a set of 2's that match, so that tells me that m is going to have a 2 out front, and then a leftover 5 will return back to the radical. So our simplified exact answer for m should be 2 root 5. We don't want to leave it as root 20. Okay, so for all of those examples, one of the legs was given to us in our special right triangle, our 45, 45, 90. The next section, we're going to be given the hypotenuse instead. So I want you to pay attention to how this is different than the problems that we've already done. We still have 45, 45, 90 as our angles. So that means that our two legs are still attached to that 90-degree angle, and they're both equal to L. And our hypotenuse is still across from that right angle, and it's equal to L root 2. I don't have straightforward information for what L is equal to, though, because those are both variables. So this is why at the beginning we did some solving. For these problems, you're going to have to isolate this L by solving. In some cases, dividing by root 2 is very simple because there's a root 2 on both sides to reduce away. And so that tells me that my L value is just equal to 6. And once we know it, we plug it in everywhere just like we did before. So 6 is equal to m, and 6 is equal to n. We can't quite squeeze it in on top of that, so I'm just going to write it to the side. Continuing on in the same way, we've got our 45, 45, 90. So the two legs attached to the 90 are both L. Across from the 90 is going to be L root 2. I don't know what L is, so I'm going to simplify. Well, not really simplify, solve, and then simplify. So this is going to tell me that L is equal to root 10 divided by root 2, which is root 5. 5 is prime, so I can't simplify it, but now that I know my L, I'll plug it in everywhere I see L. So n is root 5 and m is root 5. So far, we've had pretty good luck with dividing by root 2. We haven't run into anything kind of difficult like our intro, but I think that's about to change here with example 10. We still have 45, 45, 90. So the two legs attached to the 90 are still both L. Across from the 90 is still the hypotenuse, that's L times root 2. But now we have a problem, because when we try to divide by root 2, we get stuck. An integer divided by a radical is not something that we're allowed to leave as our answer. So I'm going to write this over here off to the side so we've got a little bit more space. Remember when we did this before, I said there were two options. I'm going to show you both of them here so you can kind of choose which one you like the best. Option number 1 is that you do what's called rationalizing the denominator. So when that root 2 gets stuck, you multiply in the numerator and the denominator by that radical. The root 2's are going to divide here to make 1, so that side is just equal to L. The numerator is 4 root 2. The denominator is root 2 times root 2, which is either root 4 and then simplifies, or you can think about it as root 2 squared, which simplifies. Either way, you get a 2 for the denominator, and 4 divided by 2 is possible. So 2 root 2 is going to be our simplified answer for L, which can then be plugged in everywhere you see an L to finish out the problem. The alternative there, if you don't like the rationalizing of the denominator, is when you see that you need to divide but you can't, we come in instead and we multiply by root 2 on both sides, which doesn't cause the L to be isolated yet, but it does change it and make it into a 2L, and then a 4 root 2 on the other side. Then you can finish your solving by dividing by a regular 2, and L turns out to be the same 2 root 2. It's just two different little options in terms of how to do that manipulation. All right, 3 more examples for this page. I still see 45, 45, 90. So our legs attached to the right angle will always both be equal to L, and our hypotenuse will be equal to L times root 2. I don't have an L available, so I need to solve for it, and I'm going to have a root 2 that gets stuck in the denominator again. So go ahead and pause it and try to decide which of these 2 methods you like the ones we did in example 10, and then come back here and check and see how you did. Okay, I've got both methods on the paper here. If you're going to rationalize, you're looking at this top section. If you're going to multiply by root 2 when you get stuck, you're looking at this bottom section. Either way, we're going to end up with L equal to 9 root 2 over 2. So if we plug that in everywhere that we see an L, we're going to end up with 9 root 2 over 2 equal to V. And then U also will be equal to 9 root 2 over 2. I see a 45, 45, 90 again here for example 12. That's going to be pretty consistent today because this is the only kind of triangle we're looking at. But after we get through the next lesson, you'll realize that this isn't the only kind of triangle we'll deal with for this standard. So it's worth looking at the angles and making sure that you're in the type of triangle you think you are. So I've got everything labeled up here. This one's not going to cause a problem when I divide both sides by root 2. There's a root ready and waiting there. Those are going to simplify to be 1, so 3 is going to equal L, which means y is 3, and 3 is equal to x. Last one on this page, I see 45 and 90, so I know I'm still in my 45, 45, 90, where the 2 legs equal L, and the hypotenuse equals L times root 2. I can look ahead and notice that dividing by root 2 is going to be no problem at all because there's a root 6 sitting there ready to go. So L will be a 3 root 3 when that is simplified, which means y is equal to 3 root 3 when we plug it in, and x is equal to 3 root 3 when we plug it in. All right, go ahead and flip to our last page of examples, and I'll meet you back here. Okay. 6 examples left. There's nothing new to learn. We've covered all of the options that you'll see with 45, 45, 90 triangles. The only difference on this page is that they're mixed together. And so if you want an extra challenge to see if you know what you need to know, go ahead and pause and try these problems, and then just come back, check your answers. But otherwise, I'm going to walk you through these 6 questions to make sure we can flip back and forth between situations when we know the L and when we don't know the L. 45, 45, 90 tells me that my 2 legs are going to match. So both of these sides will be equal to L like we've been doing for all of our problems today. Across from the right angle is the hypotenuse, which is L times root 2. I don't know L yet, but I have a little equation here that is ready to be divided on both sides by root 2. And when that happens, I learn that L is equal to 7. Plugging that in everywhere I can, that means that 7 will tell me what y equals and what x equals. The next one, 45, 45, 90, the 2 sides connected to the right angle are the legs and are both equal to L. Across from the 90 is going to be L times root 2. And here, I'm back to knowing what L is equal to. L is root 6. So I take that root 6, I don't need to solve for it, I know it, and I plug it in everywhere I see an L. I don't have enough space to do that for this one, so I'm going to slide over here. X equals root 6 with a root 2 attached. L root 2, root 6, root 2. Multiplying those roots together starts my simplifying process, but root 12, if we think about factor trees or factor tables or perfect squares, we're going to end up being able to simplify root 12. So if we use a table maybe this time, since I did a factor tree last time, We're going to find a perfect square there in that third set of factors. So x is going to be equal to 2 root 3 when we simplify. Example 3, we've got 45, 45, 90 again, so the two legs are both equal to L. The hypotenuse across from the 90-degree angle is going to be L times root 2. I can see what L is equal to right here, so everywhere I see an L, I'm going to replace it with a 14. Y equals 14, and x equals 14 root 2. All right, last three for today. 45, 45, 90 means that both of the legs are going to match and be equal to L. The hypotenuse is always equal to L root 2. I do know what L is equal to, 5 root 2. So everywhere I see an L, I'm going to plug that 5 root 2 in. That means y is just equal to 5 root 2. But for x, I'm going to move down here so I have some space. L is 5 root 2, and then there's an additional root 2 that's multiplied. Root 2 times root 2 is root 4, or regular 2, which means we should completely simplify this and get that x is equal to 10. Number 5 has 45, 45, and 90 as the angles. So the two legs attached to the right angle are both L. The hypotenuse, forgot to draw my arrow in, across from the right angle is L root 2. I need to find the L value, so I'm dividing both by root 2, which leaves me with L equal to 5 root 3. Root 6 divided by root 2 is root 3. Plugging that in everywhere there's an L means that x is 5 root 3 and y is 5 root 3. Last one, the two legs attached to that right angle in the 45, 45, 90 are both L. And the hypotenuse is equal to L root 2. We don't have L, so we're going to need to solve for it. And this is going to be the trickiest version because an integer can't be divided by a root. So either we rationalize that denominator by multiplying the top and the bottom by root 2. That's going to leave us with 5 root 2 over 2 equal to L. 5 divided by 2 would give us a decimal, so it's best to just leave it in that format. Or if you don't like that method, remember the other option is when you need to divide, but you can't because you don't have a root available, you can choose to multiply instead. Sorry, I'm off the screen a little bit. That's going to give us a 5 root 2 on this side, and then a regular 2L. So you'll still need to divide if you use that method. You'll just end up dividing by an integer instead of a root. Either way, L is equal to 5 root 2 over 2. So that means y is equal to that value, and x is equal to that value when we plug our L's in. All right, that's it for the 45, 45, 90 triangles. We'll see you next time.